Okay, guys, so here is D-2, and I'm again going to do problems that are from the practice. So the first example I'll do is number 1 from the practice, and then the second example I'll do is number 5 from the practice. So you'll see one of each type of problem that's going to be on the practice. So here we want to find f prime of 6. So that means the derivative at 6, which means the slope of the tangent line at 6, which means the instantaneous rate of change at 6. So we're going to find that for this function. And remember, all that we've got right now to find the derivative, all we've got is a limit process, which you don't want to use unless they're specifically telling you. So we got the limit process, 2 limit processes, and the power rule. That's all that we've got at this point. And you can't use the power rule on something like this because it is not a sum of terms of this form, okay? It involves terms of this form, but it's not strictly a sum of terms of that form because you have these being multiplied. So to put it in terms of that form, you distribute. So this is still f of x. This is not f prime. I am not taking a derivative right now. I'm just distributing. Okay, so x to the first times x to the negative 4 is x to the negative 3 because you add the exponents. Okay, now it is a sum of terms of that form. And now I can take the derivative. So I go f prime of x equals 8x plus 6x to the negative 4. Now, if you put here, I saw a couple of you do this on your practices. If you put here f prime of 6 equals 8x plus 6x, that's incorrect notation because whatever this input is what is going in where the x's are. So if you had a 6 here and then x is there, that's not proper use of notation. I just want to point that out because I saw a few of you do that. So anyway, now for f prime of 6, now I put the 6 where the x's were. All right, sorry, I should have turned this on earlier. Okay, so this is 8 times 6 plus 6 times 6 to the negative 4th, okay, is 48.0046. Okay, guys, we always want at least 3 decimal places. I like to do 4 decimal places. Yeah, so that's f prime of 6. All right, now I want to show you something. In the directions on your practice, it's going to say to use Math 8 to check your answer. So I want to show you something. All right, so you go like this. You go Math, and then if you go down to number 8, this is the derivative function calculator in our calculator. So Math 8, and then it sets up like this. All right. All right, so let me write up here. So math, and then you hit 8, and then that's going to open up something like this. It's going to be D, and then you always want to put a dx in. Okay, so where that's blinking now, I'm going to put dx. That's just telling the calculator what your input variable is. And then in here, you plug the original function. So 2x minus x to the negative 4th. Okay, so I'm plugging my original function in here. 2x parentheses 2x minus x to the negative 4th. Okay, and then it does a line. And then down here, Oh, you can't even see what I'm doing. Okay, so like this. All right, so this is for you guys for later. And then down here you say what value you want the derivative at. So in this case we wanted 6. All right. So you tell your calculator, the variable, the function evaluated at here. All right, so what this means is the derivative of this evaluated at 6. Okay, oh, duh, let me show you. And then it gives it to you. All right. So you want to use that to check your answers. And then sometimes if when you're on a calculator section on the AP test, and you just need a derivative real quick, and it's inside of just a larger problem, then this is a good thing to use because it saves you time. All right, now this time, so find the average rate of change. All right, so this up here, this was the instantaneous rate of change. All right, the derivative is the instantaneous rate of change. Here we're going to find the average rate of change for this function on that interval. Okay, so average rate of change, you do not take the derivative. You don't take the derivative. So if they say average, no derivative. Average rate of change is just basically normal slope. All right, so you go, so it goes f of b minus f of a all over b minus a. That's just normal slope. All right, this is like a, that's like b. So we're doing sine of pi over 2 minus sine of 0. All right, and then you want to know, your trig stuff. All right, so 0 and pi over 2. All right, so sine of pi over 2 is 1, right? Because that's 1, 0, that's 0, 1. Sine is a y-coordinate. So this is 1 minus sine of 0 is 0 over pi over 2. So this is 1 over pi over 2, keep, change, flip. We did that all last year. All right, keep, change, flip was a huge theme. So 1 times 2 over pi. 2 over pi is the average rate of change. All right, so on the practice, guys, you're going to do a whole row of derivatives of instantaneous rate of change. Then you're going to do a whole row of average rate of change. And then there's a third section where they're all mixed up. All right, so after you do those exercises, it'll just be tattooed on your brain, the difference between them and how to do them and how to do them fast. Remember, you want to be asking yourself, and I'll say this out loud in class too, like these skill sorts of things, not only do you want to be able to do them, but you want to be able to do them fast. So if you're doing problems and you feel like they're taking you a long time, that's the indicator that you just need to do more of them. Because taking derivatives, finding average rate of change, we don't want any hesitation with those sorts of things. All right, those are just small little skills that are going to be inside of larger problems. So we've got to be, really good at them and really fast at them. All right, guys, thank you if you stuck around for that little speech, and I'll talk to you later. Bye-bye.